Okay.
All right, we're on. Okay, so we're going to get started. We have a very packed agenda today. The first thing I do is post the agenda. Jeremy, if you can post the link. Okay, there you go. I think I should be able to share this on the screen. How do you share again on this thing? Go to Emit. Click on share. Oh, Simon, you're sharing, yes. Can you just...
Is that good, or should I unshare?
Okay, well, let's start. You're first person on the agenda. So we have a very packed agenda. So Simon, you take it.
Sure. So I'd like to talk about some work that we've been doing at Corrigan recently to enhance the TC police action. So I'll just first introduce myself. My name's Simon Holman. I work for Corrigan on SmartNICs. You may know me from working at a different company, Netronome, also on SmartNICs. Corrigan has taken over some of that work and has a relationship with Netronome, and as part of that, I've transferred. So I'm going to cover two topics, which are related to each other. One is enhancement to the policer to allow it to do what we call packet per second rate limiting, which is a lot like what it sounds like. And then a slightly more involved topic, which is how we propose to model open flow metering, which is supported by Open vSwitch using the policer action. So we'll get started on the first topic. Yeah, so this is fairly straightforward. So we want the existing policer action, which has been around for quite some time. It supports quite a few things, but in its sort of usual mode of operation is you apply a rate in bytes or bits per second and a burst. So here we can see the last line on the screen. There's a 24 megabit per second rate, and it allows a certain amount of burst. If packets are under the rate, they pass. If they're over the rate, they're dropped. So we wanted to make an adjustment to this, or allow it to run in a different mode. And so as well as being able to run bytes per second, you can also do packets per second. So you can see the second to last line. Here we've added a rate. It's fairly straightforward. It's just 2,000 packets per second, and you're allowed a burst of up to 400. Now you may correctly say that, of course, that doesn't. The byte rates and the bit rates will of course diverge as packet sizes changes, but this is the desired effect. You'll notice here that we've chained two different police actions, one packets per second, one bytes per second together, and so effectively this is enforcing both. So you have to be under a certain packet rate, but you also have to be under a certain bit rate in order to proceed. In practice, I think that the ordering of these is not particularly important, but of course, in theory, there's some edge cases where it does make a difference. One of the issues we did face when implementing this, and the first patch set that we sent upstream, we actually allowed a single police action instance to do both modes, but it was correctly pointed out that this was not really necessary. Because as in this example, you can just chain two actions together. And in practice, whatever implementation you have, whether it be in hardware or in software, they're always going to be applied in some kind of order. So in this way, it makes it explicit to the user, where the user explicitly defines the version, the ordering. So I mentioned hardware offload. Being a SmartNIC vendor, we're interested in hardware offload. That's sort of the main thing we do. So of course we wanted to support the hardware offload of this. Now I won't go into a lot of detail about how the hardware offload infrastructure works, but suffice to say that it exists. And when I talk about flow rule API, that is what I'm referring to, is the infrastructure in the kernel to allow the offload of rules. So they might be TC rules, but also NetFilter uses the same infrastructure. And this has an intermediate representation. The intermediate representation, essentially, at least in the TC case, you translate your flow and your actions into a structure, a snippet of the action structure is here, so it's a union, and in this case we're making use of the police field of that union, and we've added 2 extra subfields to the police field for these extra to facilitate byte per packet per second rate limiting. The driver receives these, and as I mentioned, we only allow either byte per second or packet per second, not both at the same time, although this interface would support that. And so the driver, we taught all the drivers that make use of this, that if they see these 2 fields in bold, the burst packet or the rate packet PS fields being non-zero, they should reject the offload because it would not be supported by them at this time. We then updated our own driver to support this with some corresponding updates to the code that runs on the card. So what is the status of this? This work is actually it was completed a little while ago. So the kernel portion is fully upstream for some time now. All the relevant components were updated. It's not listed here, but we also updated IP Route 2. And this does tie into OVS. OVS can make use of this feature. It essentially creates a filter very similar to the one I displayed earlier. And that is also now upstream and will be included in the forthcoming 2.6 release. Okay, so I'll now move on to the second and last topic, which is OpenFlow meters. So firstly, I'll introduce what OpenFlow meters are, and then I'll tie it into the police. So there's similarities between these. The meters are n-band, and each band has a target either in bytes or packets per second, which does obviously tie into the previous topic. It can either drop or use apply a DSCP mark to packets that are over limit. In OVS speak, or OpenFlow speak, they're independent of flows. So a meter has a life cycle which is independent of a flow, and it may be used in one or more flows via a meter action. And of course, flows may also have one or more meter actions. So I guess in theory, you could apply the same meter multiple times, but more likely you would apply several meters in series, but different flows may use different combinations of the same meters. And they're independent of ports. So this means that a rate limit can be applied to flows which apply to different ports. So at ports, yes, sorry, I'll come back to that. So here's an example of it. If some of this terminology is foreign, it should become a little bit more clear in the following slide. So this is just some syntax to create the first line of creates a meter. It's meter number 99. That's just a handle that we will use. It's a byte per second rate meter. It could also be a packet per second, but it's not. It has a burst, which is specified later. It's type drop, so anything that's over limit will be dropped. It has a rate of 1,000 kilobits per second, so that's 1 megabit per second, and a burst of 100 bytes. And then we make use of this meter in 2 separate flows on each of 2 different devices, so 4 flows in total. So we basically take device number 1 and device number 2, and for those 2 devices, any traffic that arrives on those devices in either IP or IPv4 or IPv6 has the meter applied, and then all the packets are output to a 3rd device. So how does this relate to TC? Well, we were looking for a way to facilitate hardware offload of this feature, and the chosen way of OVS when used with the kernel to do hardware offload is TC. So we were looking for a way to model it in TC. And on the left side of this slide, it's the same as 2 slides ago. So it just describes briefly what OpenFlow meters are. And on the right side, I'm comparing that to the police action. You can see that it's pretty much, it's a very nice match. There is a few limitations. So the TC police action, at least natively, only supports one band. That is sufficient for our use case. We could probably expand that by using multiple actions in series. I might be wrong, but I couldn't see that the TC police action supports marking, but you can do that by combining with other actions. And in any case, we weren't particularly interested in that use case either. And everything else lines up very nicely. So I gave an example in the previous slide about how to configure a meter. So for those of you who are more familiar with a TC, this is the same thing translated to TC. So we create an action, and in this case, I think often people use actions in conjunction with flows, and they have the actions created when they create the flow. In this case, we create an action which is independent of any flow. It's just sitting there. And then we make use of that action, which I called number 99, but it could be anything else. Again, it's the same logic as the previous 2 slides ago. On each of 2 devices, if a packet is IPv4 or IPv6, then the policer is applied. And the policer is 1 megabit per second with a burst of 100,000 packets. And if the rate is exceeded, the packet is dropped. So it should be the same as 2 slides ago. So the most interesting part of this project was we didn't have to modify the TC policer at all, other than to add the packet per second rate limiting, which we'd already done. Everything is there. What we did have to do is extend the hardware offload API a little bit. The hardware offload API, until these changes, can only really offload actions when they come along with a flow. So we want a way to be able to offload actions that are independent of flows. And so the way we did this is we create a new TC setup type. Sorry, this has been cut up. It should cut off. It should say TC setup act. So this is a first class citizen, along with well, there's many, but U32 classifier is one example. Flower is another example. Block, which is used for offloading things like lag, is yet another. And essentially, what happens is the driver will receive events, notifications telling it that there's a new offload object. And so now that it can see that this offload object is TC setup act, if it knows how to offload that, it keeps going. If it doesn't, it rejects it. And then we had to hook the flow API into various parts of the TC code which it hadn't been before, the parts that basically control the life cycle of actions. So the action setup, which covers both addition and modification of action deletion, and statistics. So what is the status of this work? We did propose an RFC for this some months ago now, and we did receive some feedback, so thanks to everyone for that. We have addressed all the feedback, and we are planning to post fresh patches as soon as 5.15 opens, which might have opened today while I wasn't looking, but as soon as this week we're planning to do that. This does cover, of course, the flow rule, which is the main part of the change, and the implementation for our driver to make use of this. It does relate to OVS, so that's a separate set of patches for OVS, where we will teach OVS how to program TC flows or TC actions to correspond to metering configuration. So that is it. Thank you for your time. Thanks, Jamal. If there's any questions, I'd be happy to field them.
Yeah, so can you hear me?
Yes, hi.
Okay, yeah, hey. So go back to your slide, probably one more maybe leave it at this, or here. I think I saw your translation looked pretty good. Shit, my video is not showing.
Sorry.
I'm not trying to hide.
Did you want the example for the meter or the example?
No, this one is good enough. Well, yeah. This is your translation, but the comparison between what's available in TC. So first of all, good stuff. This went really smoothly. I think the code changes were very nice and small. Right.
they're not upstream yet, but it's not a huge change.
Your code is not upstream yet? I thought
we posted the RFC, but we have to propose.
Okay, I'm pretty sure I commented and I act actually, right?
Thanks.
And you even pushed. I thought you pushed some chest cases as well already.
So the packet per second rate limiting was upstream. The metering we did post patches and you commented.
Okay.
So not the final version.
So let's take the one-to-one. The N band, like you said, multiple band. So you can have a policer within a policer, and you can emulate. So the problem with when the policer was being written is the ITF has so many of these band type meters.
Yes.
That in order to support all of them, diffcell was in play in those days. We had to come up with an architecture that was modular, so you can add any band, any number of bands, one band, triple band, mark with DSCP. So how you do it is you construct the policy. I think you do not that in your bullet here. So instead of hard coding the one specific, right. So instead of hard coding a specific type of banding of meters, we just decided let's just have you can create a flow of these meters or policers and create however many bands you have. I think that war was settled. So, but sometimes it just depends on policy, right? Should you downgrade the mark? Do you want to put that in the policer code or outside? So the other one, again, the DSCP marks that could also be done with assistance of other, SKB mark could do it. For example, you could tag the DSCP mark or other priority fields. Not just the DSCP, but if you're using this in 802.1p, you could also tag those as opposed to hard coding it inside the meter. You could argue that it's probably more faster if everything is in the same code, and that there's some overhead of having multiple actions. But in software, it's really accessing a pointer.
I think. I agree with what you're saying, and one reason that I kind of glossed over the band and the marking is it wasn't important to our use case. But I think what I've learned during this project is basically what you're saying, which is that the policer action sort of takes the attitude of providing a minimalist building block, and I think that was also our experience when we did the packet per second rate limiting, because we tried to make one action instance to do two things at the same time, and it was pointed out that it's much better just to have to chain two actions because it gives you maximum flexibility.
Right. The one thing that I liked, and I think you disappeared on me on that one in the mailing list, was the idea that it's independent. That's your fourth bullet, right? It's totally independent. The TC police is also totally independent. You can create a policer and then later on bind it to a flow, right? So it's not maybe it's actually totally off. So there you go. So index.
Unless I'm misunderstanding you, that is exactly what we're doing.
Okay. I mean, in the case of, well, I'm just reading your bullets, maybe used by 0 or more flows using,
Well, by may, I mean, it may be or it may not be. You can use,
good. Gotcha.
Depending on the invocation.
Right. So you're saying there's similarities. The only difference, I guess, is the N band versus one band, right?
Yeah, and this was not an issue for us, and I agree that I believe you can construct this anyway.
Right. So I mean, I don't see any questions. Are there any questions? No. So I can continue chiming here because we're on time. The one thing I liked about you posted one of the patches, I did comment, and which is a bit controversial. That is having a way to add the meter or policer in the hardware independent and then binding it later on to a flow, right?
Yeah, so what we've done in our implementation is, so we push it all the way down to the driver, but we don't actually instantiate it in the hardware until it's used.
Yes. Okay, that's your approach.
Which I think
okay.
gives you semantically what you're describing, but the detail
Yes.
is different from the hardware perspective.
Okay, you keep the state in the driver basically. But if I look at P4, for example, P4 also has independent meters, right? They're basically it's a table with an index that points to meter attributes. And I bet you that's a lot of hardware is built like that. The one thing that TC has, which unfortunately P4 doesn't have, is the ability, not just for meters, but any other actions to be totally independent of the flow, the filter, I'm sorry. So you can create them ahead of time.
The offload mechanism we added is not specific to the policer, so it should cover all of those use cases. It's just that we're only using it for the policer at this time.
Right. So at this point, is there something wrong? Oh, okay, that's just your slides. Okay.
Sorry, my screen.
Yeah. So so I'd like to see those patches in.
Yes, I would like to see them in too, and we have prepared them, so I think we can push them out pretty soon.
There is one challenge, right, Simon? The idea of the index. You have an index in TC may not exactly match the index in hardware, for example. What you call the ID is essentially an index, right? It's an index to some array that has meters.
Yeah, so actually on the hardware, at this point, I think we're only supporting a limited number. It's not a hardware limitation, but just for this use case, that's all we need. So I think we do a fairly trivial mapping to probably numbers ranging from 0 to 3. But we do have on the OBS side, we are actually facing the problem that you describe, and you remind me that this is the one loose end we have to tie up. Because I don't want to speak too much about it because I don't recall the exact issue, but there is a mapping issue that we have to deal with.
Yes. So either you have a translation, this has created a lot of discussions, right? I would have just preferred the same indexes used in both cases, but I understand that it may not be possible, right? That the hardware may have its own.
It's not. Let me resolve the OBS issue, and then I'll explain to you how we did it. But there is a small problem there. I think in general, mapping indexes is a bit of a pain, but it's also not that difficult.
It seems there's a question from somebody else other than me. Jeremy? Oh, Stephen Heminger. Okay.
Hi, Stephen.
Stephen, can you hear us? Can you hear me now? Oh, he disappeared. Okay.
He's shy. I'm sure he'll catch me later.
Yeah. And so I think that's the main controversial thing was how do you map the index in software to the index in hardware?
Yeah, I don't remember exactly how we did it, but I think for our use case, it turned out to be trivial.
I mean, the idea of putting it in the driver was interesting.
Our general approach is to put these difficult questions onto the driver.
I can post Stephen's question on the stage here. There you go.
Okay, maybe if I unshare.
Do we have a 16-bit limit? I thought we can do 32 bits on the index. You may be.
I think it's 32.
Yes, it's 32. I think you're probably referring to the class ID. There's a major and a minor ID. Do you want to respond to that, Stephen? Do you want to come on the stage or you don't? Or you're a bit shy today? Okay, he raised his hand. All right, there you go. Let's just put him on the stage. Okay.
I don't know if I'm going to work. This last time
we can hear you.
It dropped my audio.
Yeah, okay.
The problem is more we don't have enough ID bits. It's split minor major, but we need more for a lot of people.
That is I think that's different to the.
Yeah.
The index here is for the action. I think you're talking
about
the identifier for the classifier.
Right. The class ID is split into two major minor numbers, which are 16-bit each. I think that's probably what Stephen is referring to. Yeah. So that's good stuff. If you can. Good, we discussed it because I would probably have raised it. The idea of the translation. Now you could hide it from the user. That's one way to do it. And if you keep the scheme so that it works for all actions, not just for meters, that'd be fantastic. Because there is
think
hardware
it
that
does.
can actually
We
do it.
just didn't exercise it.
Okay.
Yeah, I guess if there's a minute, I can just point out that I mentioned that we do 2 actions in sequence to combine the packet per second and the byte per second rate limit.
Yes, you did. Yeah.
And that is in keeping with the general way of TC, which is nice. But one drawback of that approach is that when looking at hardware offload, the hardware might prefer, when I say prefer, only support one or the other. So this pushes the onus of the user to know that and correctly do it. Otherwise, the driver will reject it on behalf of the hardware, or the driver has to have more logic to reorder things. So that was one advantage of having a single action instance that supported both modes simultaneously. But I'm still happy with the outcome that we have 2 separate actions because it makes it explicit.
Okay. All right. I think we can have.
Thanks everyone for your time.
Yeah. Thanks, Simon. So I'm going to bring in Kong now. Oh yeah. Let's clap for Simon, please. Show him some love.
Oh wow! Thank you.
How do I do that? I can do it as a chair, but other people could. Right. All right. So I'm going to bring Kong on now for the next session. We're doing good on time, but
I'm not entirely sure how to leave.
If you go, I think if you go up, I can remove you, but
yeah, that might be a good idea. Thanks.
Okay. All right. Yeah, I think. How do I remove you? Is a good question. I thought I knew the answer to this. Oh yeah, there. All right. See you later, Simon. All right. Hey, Kong.
Hello, can you hear me?
Yeah. You want to try and share your slides and see how it looks?
Yes. Let me see. How can I share the slide?
There is an arrow button. Yeah.
Okay. Let me see.
Oh yeah, looks good.
Okay. Let me turn my camera on. So, can you see me and also my slides?
Yes, I can see you. All right. So I'm gonna just hide myself.
Okay. Yeah, that's perfect.
And you can get started whenever you're comfortable to start. Okay.
Okay.
Thanks.
Sure. Okay. Okay. So yeah. Before I start, so I can give you a quick introduction of myself. My name is Kong Wang, and I'm a TC maintainer, and I recently joined ByteDAWN's ST team. Today I'm going to provide some TC updates since the last Netdev conference, and also want to share some of my ideas in my to-do list. So hopefully, I hope we can get some people working on some of the ideas. So yeah. This is today's agenda. So I will provide a quick update on the TC side. We don't have much update here since last year, so this should be quick. And also, I will share some of my concerns about the current code, because we have a few problems here, and I would like to get some feedback, and also if someone could help me working on the problem, that would be great. And last but not least, I will provide some ideas. Some of the ideas might be crazy, and some of the ideas I think is very doable. So, and actually one of my colleagues is already starting looking at the problem. So hopefully, I hope I can get some help from the community as well. Yeah. So since last Netdev conference, we don't have much update here. So I think the major update here, updates on the TC side are these four. Probably. So the first one is the HTTP Qgis hardware offloading. I think this is the most important one because it actually solves the very important issue, which is Qgis tree lock contention. This issue is extremely serious for the HTTP because actually in ByteDance we hit the same issue, and it prevents us from using HTTP to do the rate limiting. So with the HTTP hardware offloading, it could actually move the rate limit down to hardware, so the log condition is definitely gone. So the idea actually is pretty much similar to the MQ Qdisk. So it will map each of the HTTP class to hardware queue, and each queue is offloaded to the hardware. But because of this, actually, we missed the point of doing TC filtering and classification. So the solution here actually is, I think it's very neat. So it just leverages CRCCT Qdisk, which is literally on top of the TC layer, so it could actually install TC filters there, and do some classification before we hit the actually the HTTP Qdisk, and the actual rate limit is done by the hardware, and so this is basically how it works. I think this is very useful. We are also exploring this at ByteDance as well. The next one is the queue event block. So this name is a little bit confusing because from this name you probably don't have any idea about what it does. But actually, the idea is really simple because traditionally we only trigger the TC filter and actions when we enqueue the packets. Actually, this feature actually provides us some other places to trigger the filter and actions as well. One of the example is red Qdisk. So let's say when the red Qdisk detects congestion, it could also trigger the TC block, which contains the TC filter. So with that, actually, we could do some actions as well. So in the example I grabbed from the IP route documentation, so actually it provides a queue event block on the red Qdisk for the I think it's early drop. So when it decides to drop the package early, it actually could trigger the filters. So and if we put some action on the filter, we could do something before the kernel actually drops the package. So in this case, actually it simply mirrors the package to another device. So I think this is very flexible. Unfortunately, this is very specific to each Qdisk. It's not generic, and so if any of the Qdisk needs this feature, it would need to implement by itself. So the next one is IP fragmentation support. So this one is a little bit weird because TC is usually works on the layer 2. So if we do the RP fragmentation, actually we are kind of extending our scope to the layer 3. So fortunately, the change to on the TC side is pretty much minimum in my opinion. You probably would not even notice this feature unless you read into the mirror redirection action. So the idea here actually, the motivation here actually is to handle the over MTU size package for the mirror redirection action. So without IP fragmentation, TC actually has no idea about the device MTU. So if we redirect a package from one device to another, which has a different MTU size, so we might have some trouble. So this feature actually is to solve this problem by using the IP fragmentation. So basically, it hijacks the dev Qgis, which is called by the TC mirror redirection action. So it uses the IP fragmentation API to interact with the IP layer to do the actual work. So the change on the TC side actually is pretty much minimum. So it basically only changes the dev Qgis API, which is so far I think is only used by the mirror redirection action. So I think it's kind of okay. So we don't have much exposure to the RP layer. So the next major update is the lockless Qgis. There are not much new feature here. The reason why I want to mention it here is because we have some very important bug fixes, and technically it should only touch the lockless Qgis, which is the PPP fast. Unfortunately, everything is done on the generic layer, not actually inside the PPP fast Qgis. So that's why I want to bring this up here. And the main reason why this is hard actually is because of the Qgis scheduling. So before we make the PPP fast lockless, actually, we still use the Qgis tree log for everything, including the Qgis scheduling. So we had no problem with this. After we try to lift the Qgis tree log for the PPP fast, actually, one important thing we miss is the Qgis scheduling. And without the log, actually, it turns out this is very hard. And the fix actually is not easy to verify either. So there are a lot of different scenarios and different risk conditions. So we have to deal with this very carefully. So I think this is still a challenge because I still have no idea whether we are doing this correctly. And I have some ideas about this. I think we probably want to move the Qdisk down to each Qdisk, each specific Qdisk as well, so that PPP fast could do that without the Qdisk tree log. and other Qdisk could still use the tree lock as usual. And more importantly, I think we could also move the Qdisk scheduling part into each Qdisk as well, because we HDB Qdisk already does this kind of stuff, because when we hit the rate limit, we definitely want to throttle the Qdisk. So I think this idea is probably doable, but I'm not exactly sure this could actually help the situation about the scheduling without log stuff. So at least I think it would make the code more readable. So this is my opinion. So and we also have some other issues, and I hope I could get some help from the community. So the most important one is what I just mentioned, is the PFF fast. Because of that, because of the lockless stuff, I think is getting uglier and uglier. And actually, we are adding more logs to the PFF fast. So it's definitely not lockless. Actually, it's probably has more logs than usual. So this is very embarrassing. So yeah, and the second most important issue to me is Qdisk tree lock condition. So this is definitely serious. I know we already have the hardware offloading for the HTTP part, but generally we don't have hardware offloading for any other many other Qdisk. So I think this problem still exists, at least for other Qdisk than the HTTP one. And I do have some idea for this as well. I think we probably could try to break down the tree lock into each Qdisk or the class, so that might help, because if we could create we could map the HTTP class to each hardware queue, and if the log could break down into each class, so we could actually mitigate the lock condition, right? So unfortunately, I think the issue is not that easy, very probably, because sometimes we need to interact with the root Qdisk as well. It's not just each class could do something independently. So I think at some point we could have some issue with when we hold the lower lock, we might want to hold the upper layer lock. So the deadlock is definitely could be a very big problem. So. And the next one is, in my opinion, is some we need to take care of the TC action API, because it's really ugly. If you look at the TC action init function, it actually has, I think, more than 12 parameters already. So this is really ugly, and I don't think it's any friendly, for the TC module developers. So we definitely should improve that one. And the last one is we for the TC testing, we only have the test for the control path so far. So I definitely hope we could add more tests for the data path as well. We want to verify whether a TC filter actually is successfully hit, or or not matched. So this is this would be really helpful as well. And I also have some very big ideas here.
So
some of them,
do you want to address this
yeah.
at the end, or should we, as you keep going, maybe you should take questions on the Qdisk ideas? Sorry, the previous slide, and then we jump into the new ideas. How would you like to do this? Do you want to read after?
I would like to take questions at the end.
Okay. Let's proceed.
Okay.
Yeah.
Yeah, sure. Yeah. If you have any question, you can ask me at the end. So I only have one more slide. Yeah. So some ideas here actually, some ideas I think is kind of crazy, and some idea I think is kind of mature and is doable. So definitely I can't work on all of this by myself. And actually I have one of my colleagues is trying to help me on this one, but definitely we are not. We still need help from the community for sure. Yeah. The first one is eBPF Qgis. So this one is the one I presented at the last Linux Programmers conference. So I'm still working on this one because I have some other higher priority work to do. So the basic idea is we want a programmable Qgis so that we can plug the eBPF programs with the Qgis. So I think the major the most difficult part is the rate limiting. So I still have no idea how to do the rate limit with eBPF Qgis, but I'm still working on this one. And the second one is we hope we could have some replacement for the HTTP Qgis because the HTTP Qgis has log condition. I know we already have the EDT, and we also, but EDT is not a complete replacement because it doesn't allow any borrowing from other TC classes like HTTP. So it's not a complete one. So if we could have had a complete one, that would be really great. And the third one is what I mentioned in NetConf a few years ago. So the basic idea is currently when we do rate limiting, we throttle the Q disk if we hit the limit. Unfortunately, this will not produce any back pressure to the application layer. So I think ideally, at least for the transmission side, we could actually throttle the sockets. So the basic idea is pretty much similar to the TCP small queue. We could actually throttle the socket if we hit the bandwidth limit. So, but this is not easy, and for sure because we need to interact with the socket layer from the TC layer. So this is really hard. And the next one is TC filters. So based on the discussion on the mailing list, I think it's very reasonable to make the TC filters as standalone as the TC actions, and because they are all read only, and the only blocker, in my opinion, is probably the backward compatibility, and that is really hard. And the next one is ingress queues, because on ingress side actually we TC is next to the NiPi layer, and I think that's the reason why we don't have queues there, because it's not easy to add one. And if we could have queues there, I think we could actually install all the TC queue disks on the ingress side as well. So, and the reason actually is not is not actually just for the for installing the queue disk. Actually, is my concern actually is trying to do the traffic shipping on the ingress side, because we have a lot of requests want to do the rate limit for ingress, but this is another topic, and I think it's actually even harder than just adding some queues on the on the TC side, because we actually want to throttle the source of the traffic, not just on the destination side. So this is kind of some research ideas. I have no. I don't have any more ideas about how to do the traffic shaping for the ingress side. So TCP definitely has something. We possibly could leverage the TCP congestion control window. So that's for sure. Unfortunately, beyond the TCP, I don't have much idea about how to throttle the source of the traffic. So the last one is the eBPF iterator. So because eBPF iterator could dump many kernel resources, so I think it's doable to let the iterator dump all the TC stuff as well, including QDisk, filters, and action. However, I'm not sure it's this is how useful this is, because IP router is doing really great work. I don't feel much requirement to to do the customized dump with eBPF. So, but I just want to bring this idea up, and yeah, that's all I have. So, Jimo, I think we can I can take a question.
Okay, Jeremy, you're watching the poll, I guess. Yeah, don't take your slides off yet, Kong.
Okay.
Are you watching the poll and questions? I can start. I can, if you go back to the the last two slides. So I don't want this to turn into just you and me back and forth, but hopefully some other people will chime in. Yes, I agree with you. P5 is getting ugly. Right? The problem is okay. So the problem is P5 is supposed to be classless, so it's can only work as a queue inside a scheduler, right? And there's a lot of things when people solve the specific use case that keep forgetting about the bigger picture. So, but I don't know what to do about this. I mean, it's already in there. It's very widely used. I noticed there are a lot of exchanges back and forth between in the mailing list. I was following, but I wasn't participating. So I don't know what the conclusion is. I noticed a few patches trying to work around the lock issues, right? So what do we do?
I don't have any conclusion yet. I'm still doing some research. I think we might want to move the QDisk log down to each QDisk, because P5 fast would definitely not use that one, and if we could also move the QDisk scheduling decision in to each QDisk, I think that will also help a lot, probably. Yeah, because currently we schedule the QDisk on the in the generic layer, and that's the reason why the log brings a lot of troubles if we for the P5 fast, because it doesn't use this log.
Yeah, so that may work. Would it work for schedulers though if you start bringing the lock in? Because there's some QDisks that are both classful and can be used within another class. Like they could be embedded inside in a hierarchy, right? Like for example, well, P5 was easy. TBF, I think TBF now can do classful. I can't remember, but it used to be you can just stick it into a scheduler. Would that affect that scenario?
I think it's okay, because at least the HTTP QDisk actually schedules the QDisk for the read limit as well, because it needs to throttle the QDisk when it hits the read limit.
Yes. So HTTP is a good example of something. If it works for HTTP, I think it should solve the general problem.
Yeah.
Right. Yeah. Look, unfortunately, we cannot avoid a lock, right? When you have multiple producers to a single consumer, which is the hardware, you have to have a lock. I don't care how much of a genius you think you are in computer science. You have to have some restricted region where packets get exchanged. Okay. Yes, TC Action Init API. I agree with you. It's kind of embarrassing, but it has grown a lot of horns over time. We keep adding new things, and then the best place to add it is in TC Init, Action Init. So, what's your thinking? What's your plan here?
I'm thinking whether if we could break down the API into two parts, like for the TC filters, we have the init API, we also have the change API. So the init API will only allocate a new one, and the change API will also only change an existing one. So currently for the TC action, actually we mix these two into the init API. This is one major reason.
Yeah. Okay. So you have some patches coming for that.
Not yet.
Data path testing. I don't know if Marcelo is here and David and Vlad. We do have these weekly meetings where we talk about this stuff. We do. So what kind of scale? Are you looking at performance or just sending a packet or two, making sure it's working?
I need some functionality test, not for performance. So I want to make sure. Yeah, some TC filter could really match some package, right?
Yeah. So basically, just send a packet and see that maybe it hits a filter, and then the correct action is executed. So something like a network namespace would be good enough for testing that.
Yes.
Yeah. We did try to. Okay. So it seems like maybe. Okay, Marcelo's here. Yeah, okay. Yeah, Marcelo, do you want to speak to it?
Hey, hi.
Yeah.
Can you hear me?
Mm-hmm. We can hear you.
Cool. So yeah, TDC has support for SCAPI testing already, and I did submit a test perhaps 3 weeks ago or 4 weeks ago.
I saw that.
It tested a collision that would happen on contract entries using the CT action.
Yeah, I actually saw that. Okay, so we do have this, and do you feel that it can be incorporated inside TDC for the basic stuff? I'm not talking about performance.
It is on TDC already.
No, I mean as a generic approach, right? Where the TDC then will check if, let's say, a filter is being hit. Or would that work?
Yeah, I think so. The test condition that I had in there, it dumps proc net and fcontract and looks if it has 1 or 2 entries in there.
Mm-hmm.
It could also dump TC filters and check stats.
Okay. Yeah, would that satisfy you, Kong?
Oh yes, of course, yeah.
Okay.
And it even has support now to send multiple packets. So.
Okay. So I think this is probably so you construct your packets using SCAPI, basically.
Yes.
Okay. Yeah, so it'd be very interesting if we start doing things like fuzzy testing. You generate like rogue packets and see what happens, if the kernel will crash or not. Just some idea, right? Because see if the parser is working. Catch net flow dissector behaving badly, for example, with flow. Okay.
I see a comment from David is saying that we have net forwarding tests for that.
Do you want to come on stage, David? I'm not sure what that. Yeah, so I see a comment from Alex Ehring saying he found a lot of issues with SCAPI and IFE. Okay, David has a session later on. He can probably talk about that. Okay. Your next slide, Kong. Yeah. So what does the eBPF QDisk replace some QDisk or an additional QDisk, or it just uses the ops that QDisks have?
It's a new QDisk, and it doesn't replace anyone, but actually it could actually allow us to write literally any kind of QDisk, I hope, yeah. But I don't think we can make it as flexible as that one, but still some flexibility, yeah, sure.
Okay, so it's not just a hook point into the QDisk layer. It's you actually could write appropriate schedulers or queuing mechanisms using this.
Yes, that's correct, and I'm not using the structural ops for the eBPF QDisk because it requires because it's still a QDisk. We still need to queue the package somewhere. So actually, eBPF doesn't have any kind of this stuff. That's why I'm still using the QDisk to queue the package. But the decision actually is made by the eBPF program to do classification and to order the package within the queue. Yeah.
Okay. So the eBPF doesn't hold the queues. The queues are still inside the kernel proper.
Correct.
Yeah. Didn't quite catch the idea of complete HTTP, but I'm not sure if that's probably a whole presentation. I like EDT these days, mostly because of its integration with eBPF as well as being able to bypass the QDisk lock. The back pressure idea, yes. So TCP does. You noted that in your presentation that TCP takes care of the return codes from QDisks. Let's say when a packet gets dropped, but that's only to improve congestion control, right? It doesn't do any. The application doesn't have any idea that basically the only way you rate limit because the socket queue gets full at some point and congestion control. So it works well with TCP because you have congestion enablement, right? So the socket queue gets filled up. The kernel is pulling from the socket queue, trying to send it to the QDisk, gets dropped there, and it backs off a little bit, right? That's what.
No. Actually, I think this idea is for all kind of sockets because we could actually let's say if the socket transmission allows blocking, we could actually just block the process when we try to do the back pressure because we are still in the process context, so we could definitely block.
Okay, so you're blocking all the application gets notified somehow, or so it gets to know that there's congestion.
Yeah, the socket will be blocked if it's allowed, or we could return some error if it's non-blocking. So that's my idea. It's pretty much similar to the TCP small queue.
Oh, it's TCP small queue. Sorry, I thought you were talking about congestion control. Okay.
No.
Okay, so it's a sort of a signal to back off a little bit, or so currently though, if you write to a socket and it's full, right, you get the E again return code in user space. You're saying that's not sufficient in this case?
The problem is currently if the socket try to send some package and it hit the rate limit on the, let's say, on the HTTP side, it will propagate some return value to the application. So the application could still continue to send more packages if it really want. Mm-hmm. So basically, the idea is we want to force the socket, the other application to to slow down the transmission.
Okay. Standalone TC filters. I think I kind of understood this, but do you just want to spend like 10 seconds describing it again?
TC filters. Currently, we can only create the filters, on TC class. So, but for the TC actions, actually, we could create the actions without any Qgis. And we could attach the action later with the filter. So the idea is pretty much similar. Yeah.
Got you. So you don't attach it to a block or a net device. You just later on you can bind it to a specific.
Exactly.
Sounds like a lot of work, though, right? The infrastructure
yes.
change.
Yes.
Yeah, but I hear you. So it makes sense. I mean, the idea of block helped a little bit, where you can group ports into a block, and that was the next best idea. And ingress queues. So I'll give you some history of ingress queues. Yes, I think as you noted in your presentation that packets are going up the stack. It wasn't very useful to queue them before they again get queued at the socket layer, for example. There is, and I think it's still the backlog queue, which is the per device backlog queue.
Yep. So
what we ended up doing was the IFB device, because devices are very good at describing queues. You have an enqueue, dequeue, right? On any device, you can send packets. You can send packets in and out. So the abstraction of a port is very nice for that perspective. So IFB was used for that, and you can apply shaping on IFB if you wanted. Would that not solve your 2 bullets? Both ingress queues and ingress shaping?
Yeah, I know we can use IFB, but it's kind of not very convenient, because we have to add another stuff here. And,
you have to create a
and
device.
For the traffic shaping, actually is like I mentioned, is pretty much harder than just queues, because we ideally we want to rate limit the source of traffic, not on the destination side. So we definitely want to propagate some information back to the source, but that one is really hard.
So what's your idea? How are you gonna expose this inside the kernel?
I have no idea yet.
Okay. Yeah. Okay. So all right. The BPF iterator, which level are we talking about? The TC eBPF level? Not sure.
It's on the it's for the TC, because eBPF iterator could dump different kind of kernel structures, like sockets. So it's pretty much could replace the SS command. Yeah, and actually the idea here is actually we could use eBPF iterator to replace TC dump command.
Okay, I hear you. But why does it have to be eBPF? Could it? Okay, so you want to access the same information that you get through a dump, basically, but through eBPF.
Yes.
Okay, got you. All right, so I'm. Anybody else with questions? We're still on time. We're doing okay on time. Anybody else with a question? Do you want to stay for this? Kong, since you're maintainer, there may be some questions you have to answer. You can mute yourself and put yourself on.
Okay.
Yeah. So next is Rohit. Rohit, you there?
Yeah.
Okay. All right. So Rohit, try your slides and see if they work or not.
Okay. So I just how do I share it?
Yeah, there's an arrow button, up arrow below your. Right. Just look at yourself. See, well. Right below, look, what do you see at the bottom? It says live on the left-hand side, and then go towards the right, you see the camera where you, right now you're not on video, right? You see the up arrow?
Yeah.
Okay, that's how you share. Okay, I'm going to mute myself now.
Okay.
It's right beside your mic, right beside your mic. Do you see that?
Yeah. Probably I need to restart, I think, because I think there is some problem with the sharing.
Okay. What's next in our agenda? Let me just see. Maybe it will let you off and then.
Okay. I'll just reconnect back because I think it is asking me to restart the browser.
Okay. So how about we just move to the next agenda? Pedro, are you there? I'll bring in Pedro and then.
Okay.
While you prepare there, okay?
Okay. Thanks. Okay.
Yeah. Okay. All right, Pedro. You're gonna need to turn your mic on. I think it says your permission is denied for mic. Pedro could not join because permission for the mic is blocked. All right, Pedro is also retrying. We'll give him a minute or two. Next on the schedule was David. Are you available to talk? Okay, let's try Pedro again first, and then we'll see if he comes on. We're good. All right, he is on the stage. And with that, I'm just going to hide myself. I'm going to mute myself.
Hi, can you hear me?
Yes, I can hear you.
Okay. Let me share my screen. Ooh. I think I got the same problem as Rohit. Wait a second.
Hey Jamal, I think, can you see my screen now? I'm able to share.
Oh. Yeah, so
yes, I can see your screen. Okay, so you beat Pedro. Maybe you go ahead then. Pedro, you can wait.
Yeah.
You can stay there if you want. Do you want to test your slides before we go, Pedro? Oh, well, you can't. There can only be one share. All right, go ahead. Okay, so let's mute ourselves.
Yeah. Can you see my screen now?
Yes, absolutely. You can make it full screen if you wanted, etc. So it should all work.
Yeah. Okay. Hey, I'm Rohit. I currently work in Network BU in NVIDIA. So this talk is about some of the learnings we had while hardware offloading and the kernel bridging and routing entries for EVPN using TC. Yeah, I think Rupa Prabhu is another presenter. I think she may join, but she may join later in the presentation. Okay, just to kind of set the context here, I'm just using some sample config over here so that it will be easy to map the rules we are going to look at later in the slides. So it's just a simple config where we have a bridge and with couple of access ports. Since we are also not going to talk about EVPN FDP entries and route entries, I've considered one L2 VNI and L3 VNI config as well, and it has also got some bridge access ports and SVIs as well. I have not put the routing config here, just for the sake of discussion. I just took this config as of now. Yeah, so basically I'm just going take some example of the FDP entries and the route entries and see how the TC rule look like and how we can we would have a better ones. So in this one, like I'm presenting an FDP entry where the first one is a MAC pointing to VXLAN interface which is going over the tunnel, and the bottom two the bottom two entries are the locally learned MACs, so which directly points to the access ports here. So now when we look at how the TC rule gets translated, these FDP entries are something like this. So this is for the EVPN entries where the MAC points to the VXLAN interface. So in here, what we can see that the rule is matching on the ingress interface and the MAC, the destination MAC, and the action is to put the tunnel, set the tunnel, and then redirect to corresponding appropriate VXLAN interface, which is here the VNI 10. The one thing what we can see here is that so these the NCAP rules has to be replicated for all the member ports belonging to the same VLAN. So we can't share the rule, like we don't have something like a common FDB table where I can share this FDB table across the ports. Instead, what we have here is that the rules are getting formed for each of the ports, member ports in the same VLAN. And similarly for the decap case, the packets coming from the uplink in the case of the VXLAN. So what happens is so basically we are matching on the inner MAC and the tunnel destination IP, and then we are matching on the VXLAN VNI ID, and based if it matches, then we kind of decap the tunnel and then redirect to the appropriate interface. Here as well, what you can see here is that these are the two locally learned MACs, but for each of the MACs, I need to have this decap rule. Again, here I don't have a separate. I can't have something a two-stage approach where I can just decap and go to a common FDP and do the lookup in that table. So basically, just to summarize, what we learned from here is that currently with the TC infra, we can't have the rules which can share across the member ports of the same VLAN. Basically, we need to replicate the rules among all the ports belonging to the same VLAN. And similarly, and also this also requires an implicit TC rule generation. For example, for every locally learned MAC, I need to come up with a decap rule, TC rule as well. So which becomes managing the code becomes a bit complex if you have to do implicitly these things. So coming to the next one, so in the EVPN route case, so here also I've picked up two routes. One EVPN route where the route points to the tunnel interface and also the tunnel outgoing destination IP. These are learned over the BGP, and then I also taken couple of bunch of locally NAI entries which are locally learned. So in the case of the EVPN routes, the NCAP case, the translation of the TC rule looks like this. Basically, we match on the ingress interface again and the destination IP, and then the action here is that we do the L2 rewrite and then set the tunnel action, set the tunnel header, and put the corresponding VNI ID, and then redirect to the appropriate VXLAN L3 VNI interface. So here also, as you can see, we need to replicate the TC rules for all the ports which are belonging to the same VRF. Again, here we don't have something like I can't have a route table kind of here where I can have the specific match criteria in the route table and can share across these ports. But instead, what we are having land up in having is a separate rule for each of the ports belonging to the same VRF. Similarly, on the decap and the RX direction for the packets coming over the tunnel for the uplink, we match on the inner IP and also the tunnel destination IP, and then the VNI L3 VNI ID, and then we do the decap and then do the L2 rewrite and redirect to the corresponding ports. Here in this case as well, we need to have this the decap rule for each of the local line entries. So the what we found is that in the case of EVPN routes, also similar to the same as similar to the EVPN bridge case as well, where we can't share the rules, and also we need to replicate the rules implicitly here. Again, here this also suffer the same issues what we found in the bridging case. So what we think is the possible options to improve is that if you can have add a support for metadata. So basically, to add a support for both for setting the metadata and also match for the metadata as a match pattern. This will help in splitting the rules into two, and we can share the later part with the later part of the match criteria, like for example FDP entries or the route entries across the ports. And also the another constraint we hit upon is that the decap action currently needs to be a terminal action. Basically, we need to do it only at the end. So if we can do this we can remove this limitation. We can also do this decap earlier in the pipeline, and then use the packet flow what we use in the normal case. This is also will help. I think this is just a suggestion how we can do that. This slide talks about how we can, with the metadata, we can help us in sharing and simplify the things. So as soon as the packet comes, we can have a table 0 where the demux table which will set the metadata. Then appropriately it will be redirected to the table 1 or table 2, depending upon if it's an L2 entry or an L3 entry. Again, in the L2 entries, we can match on the metadata plus the max and take the appropriate action. Similarly, for the L3 entries, we can match on the metadata plus the destination IP and take the appropriate action. So this is some of the possible way we can implement the metadata thing, where we can specify, for example, in the L3 case, we can specify the set metadata action, and then we can later in the pipeline we can match on this metadata to take the L3 action. And similarly for the L2 case as well, based on the incoming port and the VLAN, we can set the metadata, and then in the later in the pipeline we can match on this metadata and do the appropriate L2 forwarding. I think that's all I had. If you have any questions, I can take now.
Yeah, Jeremy, you're watching the. All right, you're watching the Paul. Sorry, the QA. Okay. So I think I understood what you're trying to do. But if you leave it just here, so have you looked at using the SKB mark, for example, as your metadata? Have you thought about it? Looked into it? No, because Sorry, go ahead.
Yeah, the thing is, SKB mark. The problem is for offloading in the hardware, that may not be helpful, right? I'm not sure. I don't completely understand SKB mark, but I think that.
So you said you worked for NVIDIA, right? So your driver should support SKB mark offloading today. I think it's actually being set on Ingress. You can request for it to be set.
Okay.
Right. So in other words, so I don't know if this is exactly how you would express it using SKB mark, but action SKB mark set some value, and then your subsequent rule. Either you can extend flower to look up SKB mark instead of this meta one, or sorry, go ahead.
Yeah, we can set that mark. Whether we can in the flower, I didn't find a way we can specify it's a matching criteria.
All right, so flower does not. I don't believe it supports today matching on SKB mark.
Yeah.
U32 does, for example, as another classifier. But it was supposed to be temporary, but it seems to make sense sometimes to have everything in one spot. So it may make sense in this case to maybe add flower SKB mark support.
Okay.
Now I don't know how we map that to your hardware offload, because today, and this doesn't say where. Is this on ingress or egress? I couldn't tell from your rules.
Yeah, this is for the ingress actually.
On the ingress.
Yeah.
Okay, so if you're offloading, I guess if you're offloading SKB mark, it's almost, if I remember correctly, action SKB mark means that should work today actually, right? Because I could be wrong. I did work with OR at one point where we were setting the SKB mark in the DX6 or DX5, sorry, ConnectX5, I think it was, which would set it in hardware. And so by the time it showed up to software, to the kernel, we would use the FW mark classifier, which classifies based on SKB mark. So instead of using flower, you would use SKB mark. But that was a very specific use case. So your first rule is being offloaded. Your second rule is in software, yes? Or where is that?
Even that is also in the hardware.
That's also in hardware. I couldn't tell because you didn't say skip software there. So I thought it's in. Okay. So I would suggest you look at that. You go and look at if you could use SKB mark instead of inventing something new.
Okay. But we okay. One is that for the instead of set action, we can make use of the SKB mark, but still matching the that marked one. So we need to extend the flower, right, for that.
Yes, I think you'll have to. So if you want to see an example, look at U32 as a classifier. It could match on SKB mark as well.
Okay.
Unless you're using SKB mark for something else, there's a lot of people who have somehow hard coded their applications to depend on SKB mark being used for something.
Okay.
So if you're in that kind of scenario, then we have a problem.
Okay.
And if you want to stick around afterwards, we can at break time we can sit on a table. We can grab a table at the lounge and chit chat there, and maybe you can show some more examples like using policies or code.
Okay. Sure.
Yeah. All right. Any other questions? It was just me asking questions today. No other questions. All right. So we'll thanks. Let's give an applause to Rohit. Thank you, Rohit.
Thank you.
All right. So we'll see you later. If you can let go of the sharing, Pedro can try it out.
Yeah.
All right, Pedro, you're next. All right, Rohit, I'm going to remove you from the screen. Is that okay?
Yeah, sure. Thanks.
Okay. All right. Bye. Okay, Pedro.
Okay, can you guys see it? Okay, so the thumbs up, I suppose, if you guys can see.
Yeah, it's working.
Yeah, so I'm gonna talk about replacing the flow dissector. Keep in mind, this is also a topic for another talk that Tom is gonna give. This is more like a preview of that talk. So the state of the art for the flow dissector is that it's used by classifiers nowadays. Flower is the main user of that classifier, but it's also used by others. It's also used in some net drivers, but for very specific features. It's not exactly used as a general purpose. There's also an eBPF hook for a flow dissector. You can actually write a flow dissector program in eBPF, and there's also other usages in the kernel. So the flow dissector is basically a static parser that does a bunch of things. So it supports many protocols, and it also has a fine-grained control over which keys you're going to extract when you're parsing. But it's not exactly great at handling a couple of corner cases. So for instance, handling tunneling is a big problem. It was also a topic of a recent discussion in the mailing list. And if you're only interested in a small subset of the flow dissector, you cannot exactly miss out the performance overhead of the other part. So for instance, if you're interested in just a 5-tuple parser, what exactly do you do? So nowadays you cannot do much. You need to use the flow dissector. And although we have the control over the keys, there is a performance overhead, and Tom's gonna go into more details in his talk. So what's the key idea here is to have the parser as a dynamic component of the classifier. So the main goal is to obviously overcome the flow dissector limitations. So the key point would be better performance. Also, while we get better performance, increase the ability to handle tunneling. Also, better maintainability. I invite you guys to see the flow dissector code. It's pretty messy. And also better flexibility. So if you're just interested in a small subset of tuples, you can just write your specific code for that. Yeah, so that image is not exactly that great, but so the architecture borrows a lot from the IFE action. The idea is to have a way to register this parser via TC. It's pretty easy to do via the command line. Once you get that parser visible to the classifier, we then associate it to a filter as the user registers those filters. And then once we get the SKB to do the classification, we invoke it through an entry point, which we can then save in a struct ops, for instance. It's pretty analogous to the IFE architecture, and which is something that we are heavily borrowing from. So, as for final thoughts, if this got you interested and you want to know more, don't miss Tom's talk. He's going to go over a lot more details on this topic. If you can't wait, you can hit up either Tom or me, and then we can talk about it. And as a final thought and parting thought, the ultimate goal is to have programmable parsing offloading. So the idea would be that you have a hardware that accelerates parsing for you, but not a static hardware, but a programmable hardware. So I think that's it, Jamal. I can take questions. No?
Okay, anybody with questions? I see Tom on the chat line. If you want to comment, Tom, just go on, raise your hand and I can bring you in. So the general idea is, I think I see from Tom's comment, is unlike the flow classifier, which has a lot of issues. If you bring back one of your slides, Pedro, the most recent one being Flower was unable to, yeah, the bullet which says, sorry, I think it's the, which one was that? I was having some discussion. Yeah, was it the first one that had problems? Yes, that first bullet. Flower basically was by virtue of using the flow dissector, had issues understanding, let's say, tunneled headers. It's very well tuned and in some cases hard coded to handle VLAN inside VLANs, but this one was, I believe this was a PPOE header, which had a protocol header inside it that could be, I don't remember the exact details, but it was a tunnel inside a tunnel, and basically the classifier was presented with the wrong headers, and I think this is very inherent in the flow dissector. Anyway, I'll leave it at that. Then if Tom, you want to, okay, Tom wants to make a comment, so maybe we'll hand him the mic here. All right, Tom.
Okay, so Pedro, thank you for the nice preview.
Oh, okay.
Can you hear me now?
Yep.
All right. Yeah, I was just thanking Pedro for the nice preview. So I would point out that this work is actually ongoing. We do intend to have this first cut of this actually in the next few days. It's part of the Panda software project. I'll cover that next week. A few comments. So I think since this is TC, it's good to focus on the interaction with TC. The general topic that we're approaching, which will be more about, we'll cover more in the talk, is kind of what it says. We took a look at flow dissector. It's a major function in the kernel. I for a long time, I call it the function you love to hate. It's incredibly useful, very cool in what it does, but as Pedro said, it's basically spaghetti. And there's reasons for that. It's not like we intended it to be this way. Actually, if you go way back in history, even before we called it flow dissector, there were the small ones. I actually probably did one of the first ones for RPS. But when you have something useful like that, people tend to find new uses, and over time it really kind of swelled. But the thing is, as useful as it is, it's really inherently limited how useful it is. So tunneling support is poor, as Pedro said. Adding new protocols, as I commented on, it's just really hard. If you want to do a custom protocol for your own site, that's right out. You can do it in eBPF.
Okay, Tom disappeared. That's what happens. Okay. Anyway, Pedro, I'm just gonna bring
Tom's back.
Tom is back. Tom, you have 1 minute to wrap that up. Tom? Oh. Okay, Tom, just I'll give you a minute or two.
Okay, so I'll finish up. So short answer is we'll look at this problem, how to basically eventually replace flow dissector with something much more modular, something much more programmable. We also have plans, as Pedro said, to get into hardware, but even before that, I think we can have better integration with TC to make TC itself be much more programmable. So if you want to add custom protocols and things like that. So I think the talk happens next week. I'm not sure when it was scheduled, but feel free to join in on that one.
All right. Join. It's an interesting talk. Please plan to show up there. Okay, Tom, I'm going to let you off. And Pedro as well. I'm going to let you off. David, are you there? Oh, let's give an applause for Pedro. All right. All right, David is there. Okay, good. All right.
Yeah, you hear me?
Yes.
Cool.
All right. David, you're on. You can try your slide if you have a slide, or you want to share screen or whatever.
I have the slide. Let me, oh yeah, okay. Yes, the arrow. And share screen. Chrome tab. Which is this? Share.
Yeah, worked on first try. Okay. I'm off.
Okay. Okay, so hello. This short session is about TC testing status. I'm Davide Caratti. I'm working from Red Hat, and sometimes sending something upstream. So let's talk about what we have now in the current case of tests for TC. Let's talk about what happened since the last Netdev. I wasn't attending, but I know that Brianna was. That was working for the Outreach Key project, and she did the very good job of onboarding TDC on case of tests. So the outcome is that now many of us can run periodically TDC on several versions and architectures, just like a CI job. So what we have in case of tests is basically two things. One is TDC. It matches the output of human readable IP route, and it covers Qgis filters and action, even though only Qgis and actions are actually onboarded to TDC. Net forwarding is for routing, that is correct, but we also have many TC-related tests out there, and they have a pretty good interface. I tried them once in a commit, and so those tests are using the IP route JSON output, and yeah, they provide coverage mostly for TC Flower and those actions that are currently offloaded. Many of these tests are being submitted upstream by developers from NVIDIA. Just to follow up on Kong's question, I recently did one of these tests like this. And it was just assessing the capability of TC Flower and of the flow dissector of dissecting the TOS and the TTL. And like you can see, the test is very short number of lines, and it covers probably the traffic better than a SCAPI test. But it's my opinion. I think we can use in alternative either SCAPI or this infrastructure, and both have a sense. So they're not competing infrastructure. We just need to use whatever matches best our scenarios, because both of them uses namespaces. TDC, it's more focused on the TC control plane. In my opinion, this net forwarding thing is more focused to the traffic, to the data plane. That's it. So, okay, well, what do we want to do? Probably adding more coverage for case of tests. I think that for net forwarding, only a couple of Qdisks are tested, and most of the tests are on Flower and several TC action, not all the actions. So for these self-tests, probably the best thing to do is just add other tests as soon as we need them. For TC testing, I think that the K-self-test onboarding is not 100% complete, because we have still some issues with the false negative when the self-test is skipped. And I'm going to talk about this in the next slide. Another issue is that the K-self-test environment should be able to pass and configure the test timeout to TDC. Currently, the timeout is in the configuration file of TDC. But in order to run correctly into K-self-tests, it should be something that is passed by K-self-test to the TDC script. Another thing that is a long-standing to-do item on me, and Vlad requested, but I didn't have time to work on it, is to onboard some tests among the existing ones that provide some coverage for filters. Currently, we just test Qdisks and actions. Why I'm stressing the timeout and the skipped test so much? It's because I'm monitoring the output of CKI of CKI jobs, and also sometimes Linaro LKFT. And I would like also to hear somebody working on Intel K-build and know if TDC K-self-test is also run there. What I see from the output of this of all these platforms is that in TDC we don't handle properly skipped tests, and because of this, many tests that could actually pass are skipped. So TDC skips everything until the end. if the first test is marked as skipped and this does not fit well with the case of tests. I noticed sometimes in the Linaro platform that the timeout also is not respected. Probably we need to make it configurable in order to better fit Linaro LKFT. And then another thing is the dependency with IP route 2, because we discussed this sometimes in the internal meeting. Some tests depend on a kernel patch and on an IP route patch. The tests start passing when both patches are propagated into the CI systems. It would be nice to find a good way to have a skip exit code in case the IP route is not yet patched. But this is merely a design issue, so we should design, when we add the support in IP route, we should design something that enables detecting easily if the patch is not in, or the support for something is not in. And that said, open discussion. The first point is something probably Kong was discussing before. Performance tests, is it something worth doing? This is my question for you, because maybe you will have some questions later. Then second question is, shall we use a validator to detect EP route 2 JSON output and see if something might break there? And then other questions in case you have.
Okay, thanks. So let me bring Kong on stage, and Marcelo, you're there? If you're okay to come on stage as well. How do I bring Kong on stage? Marcelo? Okay. Yeah, okay. Just give me a second. I'm still learning this tool. So let's find Kong first. And invite. And then we find Marcelo. We also invite. All right. Yeah, Marcelo, you could probably partake in this testing discussion, but also you may want to give you like a minute or two afterwards to pitch the meeting we have, the monthly meeting that you run every month, once a month. But okay, let's focus on the questions that David has first. If you go back maybe a couple of slides. I'm sorry, other people, please. Kong, if you have questions, you can take the lead here. How is this continuous integration going? Are we finding any issues?
We were lucky. Well, we were lucky for TC actions because there were no breakages at all during the last weeks. I periodically monitor this, and we just had no breakages. We had one breakage on the U32 classifier, but it wasn't covered by the case of tests because, like I said before, we don't test filters. So probably this is something that we should add.
Yeah, that is.
This was a breakage that, by the way, you detected, Jamal, with Phil, and the patch was like lost because it was not applied to IP route 2.
Oh, this is the U32 issue?
Yeah, that one.
There's also recently a breakage with police, I think. There's someone who was outputting, I don't know, maybe the patch never made it, but they were not outputting hexadecimal, they're outputting
yes, exactly. So it was an IP route patch that did not propagate yet into the system.
It hadn't propagated yet. Yep. So I think the big question is, if someone posts a patch, and this also to Kong, we should try to make sure that they are running the TDC tests, right?
Yes, I think that's a good idea. Yeah, because if they change some some control plan. So I think definitely TDC could catch the error if any.
But how do we sort of mix this with patch? Sorry, the patching. So someone submitted a patch and is sitting in the patch queue. How do you somehow get it tested before it gets accepted? You know how the Intel robot does, it catches bugs before they get merged?
Actually, I have no idea. On the EPVF side, actually, they have some CI automatically running for the patchwork, but for the TC side, actually, we don't have any.
Yeah, I'm wondering, can we bandwagon into somebody who already has this? Like, is this is the Linaro one maybe the right thing? You just have to teach it to look at the patch queue.
I don't think the Linaro fits this problem because it does not work on email level. It works on commits. So it detects a breakage only once the commit is applied.
The Intel one seems to be able to work on patch queues.
Yes.
The robot, right?
Yes, I don't know how it does, but probably it has shadow wing patchwork.
Is that still proprietary, or it's open that someone can hack it and add the feature?
It's open source, and we can definitely add more tests for the Intel one.
Yeah, I think it would be very interesting to maybe teach that robot to because it already is reading the patch queues, right?
Yes.
Right. If we can teach it to just, if you see a patch that's related to TC, run the tests against it. Apply the patch and then run the test. All right. You'll have to teach it to apply both to IP route 2 and the kernel, right? Right. On your point whether we should use SCAPI with TDC versus what was the other system you pointed to earlier, David?
Yes, this one. Net forwarding. So net forwarding are tests that are KSF tests that are under net forwarding, and they leverage on a library. And on
a bash library, if I remember correctly, right? It's written in bash.
Yes.
Right.
It's written in bash, and maybe it's just shell script and not bash, but I'm not sure. Mm-hmm. And that also has some predefined topologies that uses vet and namespaces. So if you want to test a basic topology with a filter and an action and see if a certain packet matches a filter plus an action, mm-hmm. I think the quickest way is to use net forwarding. The SCAPI plugin is cool, but even more complex than what probably we need to do a functional assessment.
Yeah, so the challenge with, I think our differences is because in their case, they can probably just send a ping and routing would work or not, can be tested, right? In our case, if we are going to test classification, then I don't think just a ping will suffice to test everything we want, because you want to test if you're matching, let's say, some TCP field or some UDP deep header, right? That doesn't quite work with routing. It's more okay. There's Ido. Ido, do you want to speak about this? If you raise your hand, I can bring you in.
Okay.
Ido is I think one of the architects behind this. Okay, so I'll bring him in. There you go. All right. Oh, did we lose David now, or is he still there? David, you still there? No, we lost him. Okay.
Is there a limit of speakers?
No, it's there's only one person on the mic, so I think he was invited via the mic. So it's like a real physical mic. Only one person can be talking in that mic. But Ido knows a lot about this because he is probably, I think he probably originally wrote this. Hey, Ido.
Yeah, so just to give a short background about the motivation for net forwarding, we
you're very. I'm sorry, you're very distant, a little bit. I don't know if you can get closer to the mic or.
No, or still not.
Yeah, much better.
All right. So to give some short background about net forwarding, so like David mentioned, we are mainly using it to test hardware offload, specifically on physical switches, but the tests are engineered to work both with VTH pairs, not in namespaces, but in VRFs, and also with physical ports that are connected using a physical cable in order to emulate physical VTH pairs. So we wrote this framework because before that we used some quite complicated Python project that required us to instrument topologies using physical hosts and physical switches. But at the end of the day, we simply wanted to run IP route commands on a single machine, on a single switch. So we came up with this idea to emulate complex topologies using either VTH pairs or simply a loop cable, physical loop cable. So like we can emulate multiple switches on a single switch. And regarding the packet generation, so we are using Mausen from the NetSniff package that is available in Fedora and I guess other distributions. And it's very flexible, and you can even hand code the payload like byte by byte. And we are using it to even to test malformed packets in order to trigger specific conditions inside the ASIC.
So how do you do that? I mean, you're able to create your own special packets?
Yeah.
Okay, because that's the biggest value with Scapy, which is I think we already had a plugin in TDC. We just never used that much until recently. Because we want to test classifiers, right? If I have to generate a packet that the classifier can match or not match. So You're saying this feature is it Scapy based or?
I don't think so, but it is capable of changing a single byte and a single offset. So it's very flexible. And I see a question about can mouse and fuzz. I don't know. I never tried it.
Mm-hmm.
But the really nice thing about these tests are that in addition to the fact that they allow us to test the offloaded data path, the hardware data path, they also allow us to verify that we have the same behavior in both the software and the hardware data path by either running the tests with VTH pairs or with physical loopbacks.
Okay. I was just looking at the man page. It looks very interesting. Okay.
Yeah,
so somebody says they can't hear. They can only hear me, but not you either. I can hear you fine. Okay. So I think it's worth looking at. The TDC plugin has been there for a while, and the reason we went TDC is for two reasons. One is to create a variation of packets so that work was never done. If anybody has a student that's looking to become famous, maybe we can give them this work, right? The Google Code project or something else. I think we should be able to bring somebody on board to put time into this. The problem is nobody has time, and we just do it on as needed basis, and it may require some thinking. So maybe we need to adopt what I'm not against it. Let me put it that way. I'll just stay out of it because Marcelo, you already did that, and you said it worked just fine, right?
Yeah, it worked. Yeah.
Yeah. The one thing we can do is fuzzing. Fuzzing would be useful, as Alex was saying on the command on the chat there. That yes, he did find a few issues with IFE, IFE also has a built-in parser, so most of the issues were on the parser. So I'm suspecting we'll find a lot of probably issues with flow dissector and Flower with this, but I could be wrong. Like if you send it some malformed packets, and so it brings a new way to create some evil packets as part of the testing. Kong, what's your thought on this? Do you have a provision, one or the other, or is still under, needs to be looked into first?
For the TDC, actually, I think if we could consolidate all the TC tests into TDC, that would be great.
Mm-hmm. Yeah, so that we only have one package to run. But
Yeah.
that doesn't mean that TDC could not incorporate this package that that was mentioned by Ido here, right? Mousezan. Mousezan, I hope I'm pronouncing it right. Right. So I would say to you, David, maybe continue looking at it. And since you're very close to this, you can compare against Scapy. I know you said it was cool, that Scapy was just a cool thing to do, but we found it was useful.
Yeah, sure. Sure. Another thing is that came to my mind while preparing this short session is whether, so with TDC we are correctly checking and detecting breakages in the IP route output of things. I would say that 90% of the stuff we detect is a IP route patch that for a reason or another break the human readable output. The question is maybe one of those cool projects that we should write and assign to students that may be willing to contribute upstream is to try to validate and detect the JSON output of IP route 2.
So you're talking about some dynamic thing that was written once and then it can basically understand all kinds of features from the JSON output.
More of a schema validator. So
right. Validate of the schema. Yeah, that would be really nice. So that way we don't depend on a human not remembering, yeah, there used to be a hexadecimal over there, right? And
exactly.
why do you have a decimal? Right. Yeah, that would be
I was
really
also
cool.
thinking of that index thing that recently popped up for policy.
Yeah.
It's good that every action has an index.
Yes, and the police basically was always coded to have hexadecimal, and the person had put decimal basically. Right? That's the one you're talking about, I think. Okay. Okay, so we're running out of time. We are 5 minutes past, but it's a break for about 40 minutes or so. Marcelo, do you want to tell people about the meeting we have once a month?
Yes. So I just shared a link on the chat for the email that was sent as announcement on Netdev a couple of months ago. We had a meeting ongoing since Netdev Conf 12, but it was focused on TC testing. And recently we upgraded it to be more TC in general, not just tests. And we have this meeting once a month on the second week. It is a public meeting. Everybody's welcome to join. The last one we tried the RMeet, this very same system that we are using now, but usually we use the one that is on the email in there, Meet Kernel Social, TC Meetup. There's a Google Doc with the agenda, which is very, very open and free. I facilitate the meeting, but I don't control the agenda. So people are free to add items as they wish. And that's pretty much it. Everybody's welcome.
Yeah, thanks. Any other last minute comments? Kong, anything? Last words before we call it off?
Yeah, I think this is a really great workshop. So I want to thank everyone participating. Yeah.
Thank you. Thanks, everybody. See you on the other side.
Thanks. Bye-bye.
Thanks. Bye.
Bye. Thank you.
Okay.
Thanks.
Bye. Okay.